Today we're going to be discussing how to convert equations from polar to rectangular as well as rectangular to polar. Okay, to start off with, we have the unit circle. As you know from the Pythagorean theorem, you have x squared plus y squared equals r squared, right? You can manipulate this equation to get r equals plus or minus square root of x squared plus y squared. Make sure you do the plus and minus because it can help you get the correct answers. And because this is the unit circle, cosine of theta equals adjacent over hypotenuse, which is your radius, and sine theta equals adjacent over hypotenuse, which is your radius, and sine theta equals opposite over hypotenuse, and tangent over theta equals opposite over adjacent, right? Make sure you know these equations because they're important in converting your equations.
So, like Celeste established, tangent theta equals y over x, sine theta equals y over r, and cosine theta equals x over r. Now, so that in our equations, it's easier for us to manipulate them. We're going to establish this rule as well. X equals r cosine theta. We get this because, as we established before, cosine theta equals x over r. So all we've done is moved the r to this side so that when we're solving for in the equations, we can easily show what x equals. And we can do the same thing for y, and we can say that y equals r sine theta. This comes from the previous equation, which is sine theta equals y over r, and all we're doing is moving r over to the other side. Likewise, when we have to find out what theta is, we can say that theta equals the tangent inverse of y over x. This comes from the equation where we also established that tangent theta equals y over x, and when we have to solve for theta, all we do is the tangent inverse. So now we're going to start off with a basic problem of converting from rectangular to polar. So the problem is x squared plus y squared plus 2x equals 0. As we've already established, x squared plus y squared, as seen up here, equals r squared. So now we can just substitute r squared for that. And then we also know that x equals r cosine theta. So instead of x, we're going to put in 2r cosine theta. Because when you're converting into polar, you want to make sure that the only types of variables you have in your equation are r and theta. So from here, what we're going to do is we're going to move 2r cosine theta to the other side. This is a 0. So it becomes r squared equals negative 2r cosine theta. So now we want all of the r's on one side, so we're going to divide both sides by r, which leaves you with r equals negative 2 cosine theta. And this would be your final answer, and there you go. So now we're going to do another problem, which is also similar but a little bit different, and this is y squared equals x. So as we know, y equals r cosine theta, so since it's r sine theta, so since it's y squared, we're going to have to make sure that we square the r, and the sine theta is also squared. So it becomes r squared sine squared theta equals, we already know x is r cosine theta, so we just put that in there. And we want all of the r's on one side, so we're going to divide both sides by r, so that leaves you with r equals cosine theta. This time, we have another example for converting from rectangular to polar, and the equation is 4xy equals 9. Like we've already said, x equals r cosine theta, and y equals r sine theta. So we're going to substitute that in over here for x and y. So r cosine theta and r sine theta. So if we distribute this across, we understand that the new equation is 4r squared cosine theta sine theta. Now, so that we can do this in a more efficient way, we're going to factor out 2r squared, which leaves us with an identity, which is 2 cosine theta sine theta equals 9. As we've learned in our previous units, 2 cosine theta sine theta is also known as an identity, which is sine of 2 theta. So we're just going to put that in over here. So it's 2r squared sine of 2 theta equals 9. And there we go. We have converted an equation from rectangular to polar.
Okay, so next we're going to talk about converting equations from polar to rectangular. The first example we're going to do is theta equals 60 degrees. Now, as we established up here, tangent theta equals y over x, so theta equals tangent inverse of y over x. Since theta is 60, that's 60 degrees equals tangent inverse of y over x. So tangent of 60 equals y over x. Tangent of 60, according to the unit circle, is root 3. So root 3 equals y over x. And then if we manipulate this by multiplying both sides by x, x root 3 equals y. And that's your final rectangular equation. Another example that we're going to do is r equals 11 over 6 minus 5 cosine theta. On this one, the first step that we want to take is multiplying the bottom of this fraction by r. So it's going to turn into 6r minus 5r cosine theta equals 11. R cosine theta is the same thing as x, so this turns into 6r minus 5x equals 11. And if we move the 5x over to the other side, we have 6r equals 11 plus 5x. Now we can square both sides to make this a little bit simpler, and that will turn into 36r squared equals 5x plus 11 squared. R squared is the same as x squared plus y squared, so now we have 36x squared plus y squared equals 5x plus 11 squared. And that is your final rectangular equation. Okay, so we have another example of converting equations from polar to rectangular. This example is r equals 8 cosine of theta. Now the first step in this process is replacing cosine theta with x over r as we established previously. So r equals 8x over r. Now we need to move all the r's to one side, so we can change this to r squared equals 8x. R squared is the same thing as x squared plus y squared, so we can replace that, and so now x squared plus y squared equals 8x. If we complete the square on this situation, then we need to move over x squared minus 8x plus 16 plus y squared equals 16. Now this part of the equation changes to x minus 4 squared plus y squared equals 16. And that is your final rectangular equation.